right, what do they say? 3 times the charm. All right, so exponential growth. I'm gonna try this again. I'm malfunctioning of calculators. So the world population in 2000 was approximately 6.08 billion, and we're looking at an annual rate of increase of about 1.26%. So we're looking to first find the growth factor of the world population. So we're looking at, why do I have these two numbers here? Well, one is 100% of what we start with. So we always begin with 1 and then we adjust it accordingly, because if we multiplied anything times 1, we keep it the same. So we either have to add to it to get our exponential rate, or we're going to decrease it to get our exponential decay. So in this case, we are growing because it says increase. So we change 100% to a decimal, which is 1.00. And then we're going to take that 1.26% and change that over to a decimal, which you can see right here. So this was where the original decimal was. I moved that 2 spots over, and now I have a decimal in front of the 0 here. So we have 0.0126 as the rate of change here that's going on. So we're going to add that to the one we start with, which gives me a growth factor of 1.0126. Now it's not much, so it's not going to be a huge increase, but you will see some substantial growth over time. So now we're going to look at, how do we write the equation? So when we're writing an equation for these, we start off with f of x, and then we're going to use our whatever initial amount is, which in this case is 6.08, and then we put our growth factor in here in parentheses, and then it's followed by an exponent of the x, which is, again, whatever it is. In this case, we're talking about time, so we're going to be multiplying it by itself however many times we are looking to value that for. So then in the last question, it says, let x be the number of years past the year 2000. So find what the population would be in 2010. So I've already written this out here, so you can see f of 10. I replace the x with 10 because we're talking about 10 years difference. So that's 10 years has passed. Our initial value of 6.08, our growth factor 1.0126, and then we have that 10, which we're going to be using because it's 10 years. So on my calculator, we will try this one more time. Hopefully this time it will work. 6.08, which is what we started with. Now we're going to put times. We're going to put a parentheses. 1.0126. We're going to hit this exponent button right here and put the 10 in because it's 10 years. We're going to close that parentheses. That's just the calculation of this part right here. And then we're going to hit equals, and that's going to multiply it times our original value. And we're going to get 6.89, and that's billions. So 6.89 billion people is approximately what we would have after 10 years' time. And if you want more questions like these, you can find these all on my YouTube, Instagram, and TikTok at YouWantAlgebra. All these can be located in the exponential functions section. Don't forget to like, share, and follow for more.